Okay? Well, we have, in one corner, we have the sine of theta times the secant of theta times cotangent of theta. And in the other corner, we have a very intricate number 1.
Okay.
So let me know when you figure it out. The 1. The 1's just a little bit less complicated, it's a simpler number, okay? So we're going to just box in number 1, okay? Now let me kind of give you an overview of what we're doing here. Our goal is to get this left side. We just got to rearrange this left side, rewrite it using these identities so that somehow we can form it and morph it into the number 1 on the left side as well, okay? Now I'm going to give you a hint. These guys, super useful, okay? We want to use these all the time. I know that cotangent's equal to cosine over theta divided by sine of theta, and it's also equal to 1 over tan of theta. But if we have a choice, almost always we're going to want to use this quotient identity for the cotangent of theta, okay? So go ahead and circle those and be like, man, these are super awesome. Yeah, okay? Please, if you can write quickly. So are there any questions so far? All right, so let's start rewriting this. Also, one other thing before we begin. Sine and cosine are kind of like the building blocks. We're usually not going to really break sine and cosine up into anything smaller, if that makes sense. So the sine of theta, he is going to stay sine of theta. But how could we rewrite the secant of theta? What is the secant of theta equal to? Oh, it's 1 over the cosine of theta. So I'm just going to write that as 1 over the cosine of theta. All right. How can we rewrite the cotangent of theta? Right, we could write it as 1 over tan theta, but that's not going to help us so much. So let's use cosine of theta. Did you say why not? Over sine of theta. I can explain why not in a moment, and I will once we finish this problem, and then you'll go, oh, yes, you're right. Okay. So now, can we cancel stuff out? Sine of theta, cosine of theta, cosine of theta, and guess what we're left with? 1. So we have 1 is equal to this guy, which is 1. So we have just verified. Okay? And I'm going to let you write that down in just a minute. We're going to go back and see why 1 over tan of theta is not going to be the best option for us. So we're going to do this again, except we're going to see what happens when we use 1 over the tangent. So then we'd have sine of theta times 1 over the cosine of theta. And then we'd multiply this by just what? 1 over the tangent of theta? All right. But once we do this, then we'd multiply, and that would give us sine of theta over the cosine of theta times 1 over the tangent of theta, right? And then we know that, what's sine of theta over cosine of theta? Use your identities. This is the tangent of theta. So then we have tangent of theta times 1 over the tangent of theta. All right, and that's going to give us what?
1.
Tan of theta over the tan of theta, and then that's going to equal 1. So you could do it that way, right? But that wasn't the easy. I mean, it took us a little bit longer, right? But that wasn't wrong. There are multiple ways you can do this, okay? I'm going to go for like the less steps way, if that's okay with you guys. All right, so let's look at example number 2. In example number 2, how are we going to want to rewrite this? Or which side's the less complicated, would you say?
The left side.
All right, you may say the left side. I'm going to go with the right side. Because every time we're trying, are you listening to me? We're trying to get, can you hear me?
Yes.
We're trying to get the left side equal to the right side, okay? Please look up here when I'm speaking. Every time we're trying to get the left side equal to the right side, correct? But it's not going to be easy for us to get from sine squared to a fraction like this. You know what I mean? But if we start off with this more complicated stuff, we can try to put it together to get to sine squared. That's why that's why I've chosen to keep the right side the same. Yes, sir.
Alright, so the box, when you side with the box, and you keep it
One side has to stay the same always.
that's
So
the inside,
what's inside the box? That's what I've done. Yes, yes, yes. Okay.
It can't always be the right side, can it?
It's not going to always be the right side, and it honestly it can be either side. It can. It's just sometimes it's easier. In my opinion, it's easier to start with a more complicated side. Okay, Chloe. So let's look over here on number 2. Sine of theta is just the sine of theta, right? But can I rewrite the cosecant of theta as something? What is the cosecant of theta? Look at your identities. I even gave you a separate little... It's what? 1 over the sine of theta. Okay? And remember, guys, we saw a lot of this in that last unit we just went over. When we divide by a fraction, it's the same as multiplying by... So we're dividing, and I don't want to confuse you with this one. What we're doing is we're multiplying the sine of theta, not by 1 over the sine of theta, but by that reciprocal, which is the sine of theta over 1. And guess what the sine of theta, and we can put this over 1, times the sine of theta is? Sine squared of theta, and that's equal to, oh my goodness gracious, look what we were looking for, sine squared of theta. We have verified it. These match. Do you see that? Is that clear? Do you see that, Daniel? Yes, sir.
Well, so you found the sine of
Mhm.
theta first.
Right.
Is that how you would do it first?
No, the right side stays the same. It's like we're rearranging the left side
so
that it matches.
Of theta. Oh, okay.
Okay? All right. So let's look at example number 3. All right, guys, on example number 3, how can I rewrite the cotangent of theta? Cosine of theta over sine of theta. Times, how can we rewrite the secant of theta? 1 over the cosine of theta. Okay, now, do I have stuff that can cancel? Cosine of theta, and I'm left with 1 over the sine of theta. But guys, seriously, what's 1 over the sine of theta? The cosecant of theta, which is equal to exactly what we're looking for, which is the cosecant of theta.
So that's just it.
That's it. This was a pretty easy one, huh? Any questions? How are you feeling about this? As long as you know those identities, you should be good. It's really just playing around. I understand that number 4 is just like number 3. It was such a good problem. I wanted you guys to do that other one on your own for homework. Okay, so let's go ahead and go to number 5. I'm sorry?
So you understand number 4 is like number 3.
That's what I meant, yeah. Okay, so look at number 5. On number 5, how can we rewrite the secant, Hiram? Because we know tan of theta is what we want to leave alone, right? How do we rewrite the secant of theta? Very good. This is 1 over cosine of theta. And how can I rewrite the cosecant of theta, Alexia? How can I rewrite the cosecant of theta? One over the sine of theta. Do you guys agree?
Yeah.
Okay. So we know that when we multiply by a fraction, it's the same as, when we divide by a fraction, it's the same as multiplying by its reciprocal. So we have 1 over the cosine of theta, and we want to multiply that times what, Alexia?
Cosine of theta over...
So we already used this. Now we need to multiply it by the reciprocal of the bottom, which is what? I'm sorry? Hold on one second. Which is what, Alexia? Wait. This is 1 over sine of theta. So it's the reciprocal of that, which is the sine of theta over 1, right?
Yeah.
This is going to give us sine of theta over cosine of theta, which is just what? Alexia? which is the tan of theta. And guess what we're looking for right now? We are looking for the tangent of theta. So we're done. Yes, Matt. Matt. Well, remember, we already knew that tan is the tangent of theta is y over x. Sine is y, cosine is x. So remember, that's something we already knew. We forgot we knew it, but we know it, right? Okay. Any questions so far? All right. How are you feeling so far? Anybody? Okay, excuse me, it's gonna, I think on number 7, excuse me, on number 7, oh yeah, we can do 6, sorry. All right, so on 6, this cosecant is what? Over what? 1 over the sine of theta. I'm sorry, I forgot to tell you, we're leaving the side alone. Divided by, what is cosine of theta? I'm sorry, cotangent of theta. What'd you say? Remember, no, this is cotangent. Remember the ones I circled? They were so important, I got you to circle them. So what's cotangent?
Oh, whatever.
It's just cosine of theta over sine of theta. You thought secant was 1 over cosine? That is 1 over cosine.
This is sine. I thought we were doing that. Oh, you doing this one?
Yeah. Yeah. Okay. Hey, what's up? Hold on 1 second. I'm recording. Sorry. Cotangent of theta, okay? Kevion. Cotangent of theta, what is it? Very good, Kevion. We can rewrite the cotangent as cosine of theta over the sine of theta. All right, now we're doing that pesky old dividing by a fraction thing again, which means we really need to multiply by the reciprocal. Very good. So that's 1 over the sine of theta, and we want to multiply that by what?
Sine of theta over the cosine.
Very good. Sine of theta over the cosine of theta. Now, can we cancel some stuff out? Matt, can you see from there? Cancel some stuff out. Sine of theta, sine of theta. Do y'all see that we can cancel that out? And that's just going to give us 1 over the cosine of theta. But guys, guess what 1 over the cosine of theta is? Just guess. The secant of theta. And what are we looking for? The secant of theta. So we are happy and we found what we were looking for. All right, any questions? Is this not so bad? I mean, honestly, all we're doing is like just rewriting stuff, right?
So y'all did first
Mm-hmm.
whatever is the cos.
Yeah,
Cosecant.
right. We're just rewriting this, yeah.
Yeah.
Okay, so guys, this next problem is going to get a little bit more intricate.
Okay.
All right?
Intricate.
Yeah.
What's that?
It's a little bit more difficult. It has some more factors. Okay. Before we start with this next problem, I'm pretty sure it's this problem, but what we are going to need to know, guys, is how to eventually, well, let's just start it off. How about that? This is just, we want the right side to stay the same, and this is just the sine of theta times, what's the tangent of theta? The sine of theta divided by the cosine of theta, right? And then this is just plus the cosine of theta. And we can simplify this a little bit by just writing this as the sine squared of theta over the cosine of theta plus the cosine of theta, okay? So now you have to ask yourself, where do I go from here? That's the question you're asking yourself right now. We know that on the right side we want to end up with just one term, correct? But right now we have that plus sign, which makes us have 2 terms. So how could we end up, if we want just one term, we're going to have to put those 2 terms together, right? But we can't add these numbers because they don't have a common denominator. So how can we make them have a common denominator? Multiply. Okay, the denominator of cosine of theta is 1. So what would we need to multiply by? Cosine of theta? Would you guys agree? So we're going to multiply the numerator by the cosine of theta and the denominator by the cosine of theta. I'm just going to rewrite this term, which is sine squared of theta divided by cosine of theta plus, what's cosine of theta times cosine of theta? Very good. Cosine squared of theta. And that's over the cosine of theta? All right, now that we have common denominators, can we just add our numerators? Remember, this is just a box of remembering. If I were adding 1/3 plus 4/3, how would I add those two fractions? You add the numerator, and the denominators stay the same, right? So we add the tops, 1 and 4 is 5, but the bottom stays the same. Same story here. We add the tops, so this is sine squared of theta plus cosine squared of theta, and the bottom stays the same, which is just the cosine of theta. Now I heard somebody just say something very intuitive, and that was something as simple as the number 1. Now who said that? Who said 1? It was you? Tiffany. Why did you say 1? Because Tiffany is on it today and looked at the top where she was looking at her Pythagorean identity. She knows that the sine squared of theta plus the cosine squared of theta is just equal to 1. So she was like, get rid of all that junk in the numerator and just put a 1 there. And then what's in the denominator? Cosine of theta. And what is 1 over the cosine of theta? And is that exactly what we wanted to find?
So you kind of have to think. It's like what we reduce.
Right. Good. It's a lot. It's I say it's a lot, but I'm probably showing a lot of work that I probably don't need to. Okay? So it looks like a lot of work, but okay, let's continue. So let's look at number 8. All right, number 8 is so much easier than you think. And let me go back to number 9 to show you why. All right, so you see number 9? When we ended up here, what we did on number 9 is we put these, number 7. On number 7, we had 2 separate things, and we put them together to make one fraction, right? The point of this was to remind us how we add fractions. Okay, so this is gone. Don't worry about that. So this is the more simple side. So here, instead of putting this together as one fraction, because it already is, we can break it apart. And how would we break this apart? Well, sine of theta, they don't cancel out from the beginning. We can only cancel out if multiplication is happening. We can rewrite this as the sine of theta over the sine of theta plus the cosine of theta over the sine of theta. Right? Do you see how I did that? It's like going from the pink to orange here on that last problem we did. Do you see? Now, what's the sine of theta divided by the sine of theta? Matt? 1. And then what's the cosine of theta divided by the sine of theta? Cosine of theta over sine of theta? Cotangent of theta. And guess what? That's exactly what we were looking for. That was a pretty easy problem, right? It's the hard part. I get that the hard part is kind of like, where do you start? But that was true when you were in geometry and you had to prove things. And you're like, how am I going to prove this, okay? What you've got to do is you know that this little green sheet, this is what you got to work with. And you've got to work with this until you get the right answer. Okay? You just got to kind of work with it, trial and error. It's not something that I can just tell you how to do, because you got to be able to think and do it on your own.
Oh, so
Yes, sir.
It's easy. You just got to think.
You just got to think. That's all it takes. Just a little thinking.
All
All right?
right.
So let's look on number 9. I mean, there are some things that you need from me. Like on number 9, I would let you know on problems like this, we're going to want to go ahead and use the distributive property, right? We're going to want to distribute this 1 to each term in the second parentheses. And 1 times 1 is?
1.
And 1 times the sine of theta is?
Sine of theta.
Very good. And then we're going to distribute negative sine of theta to each term as well. So negative sine of theta times 1 is negative sine of theta. Very good. And negative sine of theta times positive sine of theta is negative sine squared theta, right? Okay?
Yeah.
Okay, so where do we go from here? What do we do with our sine of theta and our negative sine of theta? And we're just left with 1 minus the sine squared of theta, correct? All right. Well, before we continue, I want to remind you of a specific identity, okay? And that is that we're going to go over here in our little box, side box, that the sine squared of theta plus cosine squared of theta is equal to what? 1. What are we trying to get by itself? Cosine squared of theta. So if we get rid of the sine squared of theta over here, that S is struggling. Then we're just left with cosine squared of theta is equal to 1 minus sine squared of theta. So that means we can just replace this guy, 1 minus sine squared of theta, with cosine squared of theta. And of course that's equal to what we're looking for, cosine squared of theta. See? So we're good. Any questions? You really just have to see what you got and what you can do with it to get what you want to get, okay? All right, so next one. Okay, look at number 10. All right, on number 10, you can choose either side. The reason I'm choosing the right side as the more or the less intricate is just because I'd rather put things together than have to take them apart. Does that make sense? We have 2 different terms, so we're going to just have to put them together to get the right side. Do y'all see that? Okay, so how can we rewrite the tangent of theta? And this one, the last class really struggled with this, so you want to make sure that you are not distracted and that you're paying attention for this one, okay? So tangent of theta is the sine of theta divided by the cosine of theta. And this is plus, the cotangent is cosine of theta. Very good. Okay? So, if we want to put these together, what do we need to happen? We need a common denominator. And what would that common denominator be? Sine of theta times the cosine of theta. Right here we have a cosine of theta, right? What do we need? We need a sine of theta, okay? But we can't just multiply the bottom times sine of theta. That would be crazy, right? We also have to multiply the top by sine of theta. Very good. Now over here, what are we missing? What are we missing here? Cosine of theta. Very good. So then we have sine squared of theta over cosine of theta, sine of theta, that's times, plus cosine squared of theta over cosine of theta, sine of theta. All right, that was a little much, so let me know if you have any questions about what just happened here.
Why would you put sine of theta squared before all this stuff? Why would you put the square on the top? The numerator?
Oh, the reason I put the square here and not here, is that what you mean?
I mean, I know that. I mean, wait, why would you put that there first?
Are you saying why I put it here instead of here?
Well, that wasn't what I wasn't really going to say. I'm saying, why did you put those on the numerator?
Why did I put sine of theta in the numerator?
The ones that have the square in the
Because sine of theta times sine of theta is sine squared of theta. Wait, did you see that?
Oh yeah, I
So
saw that.
there's two. Does that make sense now?
Yeah, and I'm curious as why.
Well, when we write it like this, sine of theta squared, some people think that you're squaring the theta, and the theta is not what we're squaring. We're saying the sine of theta times the sine of theta, not the sine of theta times theta. Do you? Okay, let me show that. We're saying the sine of theta squared is equal to the sine of theta times the sine of theta, right?
Right.
But if you just wrote sine of theta squared, then this would mean the sine of theta times theta,
Right.
which is different.
Okay.
Okay? And I guess just so we don't have to write these parentheses every time, that's why we put the 2 here.
Okay. Yeah.
And it's sine squared of theta, which means we're sine squared of theta. Means we're multiplying sine of theta times sine of theta. It's just notation, but okay. So now can we add the numerators and leave the denominators the same as we would with any other fraction? Kevion? Yes. So we would just add at the top, and that's sine squared of theta plus cosine squared of theta all over cosine of theta times sine of theta. All right. What's in the top, though? 1. And in the bottom, we have cosine of theta times sine of theta. Now, we can rewrite this as another step. You don't actually have to do this additional step, but some of you it might help for you to see. This is the cosine of theta times 1 over the sine of theta. And the only reason I write that out for you is for you to see what is 1 over the cosine of theta equal to. The secant of theta. So now we have the secant of theta times what is 1 over the sine equal to?
The cosecant.
The cosecant of theta, okay? And that's what we wanted, right?
Yeah.
All right, how are you feeling about that?
Yeah.
What'd you say? I have it written down on a sticky note that I recycled, but I'm pretty sure that the homework, may I see this? I know it's not, no, there is homework. I want to say it's 11, 15, and maybe 19, but let me double check before you write that down. I know it's for sure 11 and for sure 15. Let me just look. $11, 15, and 19. That's it. I remembered. 11, 15, 19. Okay?